प्यारे बच्चों, ਅੱਜ ਦੇ ਪਾਠ ਡਾਇਮੈਂਸ਼ਨਲ ਐਨਾਲਿਸਿਸ ਵਿੱਚ ਜੀ ਆਇਆਂ ਨੂੰ। ਡਾਇਮੈਂਸ਼ਨਲ ਐਨਾਲਿਸਿਸ ਇੱਕ ਬਹੁਤ ਹੀ ਲਾਭਦਾਇਕ ਟੂਲ ਜਾਂ ਔਜ਼ਾਰ ਹੈ। ਇਹ ਸਿਰਫ ਆਲੋਚਨਾਤਮਕ ਸੋਚ ਨੂੰ ਹੀ ਉਤਸ਼ਾਹਿਤ ਨਹੀਂ ਕਰਦਾ, ਸਗੋਂ ਇਹ ਉਹ ਚੀਜ਼ ਹੈ ਜੋ ਹਰ ਵਿਅਕਤੀ ਰੋਜ਼ ਵਰਤਦਾ ਹੈ। ਤੁਸੀਂ ਆਪ ਵੀ ਇਸ ਧਾਰਨਾ ਨੂੰ ਬਿਨਾਂ ਅਨੁਭਵ ਕੀਤੇ ਵਰਤਿਆ ਹੋਵੇਗਾ। ਕੋਈ ਕੁਇਕ ਕੈਲਕੂਲੇਸ਼ਨ, ਉਦਾਹਰਨ ਲਈ ਜਿਵੇਂ ਜਦੋਂ ਤੁਸੀਂ ਜੇਬ ਵਿੱਚ ਕੁਝ ਪੈਸੇ ਪਾ ਕੇ ਬਾਜ਼ਾਰ ਵਿੱਚੋਂ ਕੋਈ ਫਲ ਖਰੀਦਣ ਜਾਂਦੇ ਹੋ ਤਾਂ ਅੰਦਾਜ਼ਾ ਲਗਾਉਂਦੇ ਹੋ ਕਿ ਇਹਨਾਂ ਪੈਸਿਆਂ ਨਾਲ ਕਿੰਨੇ ਫਲ ਖਰੀਦ ਸਕਦੇ ਹਾਂ ਜਾਂ ਕਿਹੜੀ ਚੀਜ਼ ਸਭ ਤੋਂ ਚੰਗੀ ਅਤੇ ਜ਼ਿਆਦਾ ਫਾਇਦੇ ਵਾਲੀ ਹੈ ਆਦਿ। ਇਹ ਵਿਸ਼ਾ ਸਿਰਫ ਸਾਇੰਟੀਫਿਕ ਕੈਲਕੂਲੇਸ਼ਨਸ ਲਈ ਹੀ ਨਹੀਂ ਹੈ, ਸਗੋਂ ਇਹ ਸਾਡੀ ਰੋਜ਼ਾਨਾ ਜ਼ਿੰਦਗੀ ਲਈ ਵੀ ਲਾਭਦਾਇਕ ਹੈ। ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਕਿ ਅਸੀਂ ਡਾਇਮੈਂਸ਼ਨਲ ਐਨਾਲਿਸਿਸ ਦੇ ਵਿਸਥਾਰ ਵਿੱਚ ਜਾਈਏ, आओ ਅਸੀਂ ਅੱਜ ਦੇ ਟੌਪਿਕ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਤੇ ਇੱਕ ਨਜ਼ਰ ਮਾਰੀਏ।
On completion of this topic, learners will be able to state the basic dimensions used to describe a physical quantity, define dimensions of a physical quantity, give the dimensions of various physical quantities, discuss how to find out the dimensions of physical quantities in terms of base units, define dimensional formula for a physical quantity along with examples, define a dimensional equation along with examples, discuss the importance of determining dimensions of a physical quantity.
An excellent example of the impacts of dimensional analysis is the failure of one of NASA's Mars mission in 1999. After the loss of the climate observer, an investigation board was put together to determine what happened to the mission, and a number of things were found to be responsible for the failure of the mission. But do you know that there was one major factor which directly affected the mission? The problem was that one team used English units, that is FPS system, while another team used metric units, which caused the craft to take a different path than proposed. In other words, there was a problem in unit conversions. Improper dimensional analysis led to a massive loss of time, money, scientific attitude, and knowledge. In physics, much importance is attached to measurements, and because of this reason, physics is also called as the science of measurement. To understand a physical situation completely, we have to measure the physical quantities. Do you remember the physical quantities? All quantities in terms of which laws of physics can be expressed and which can be measured directly or indirectly are called physical quantities. ਕਿਸੇ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦੇ ਮੈਜ਼ਰਮੈਂਟ ਲਈ ਉਸ ਦੀ ਤੁਲਨਾ ਉਸੇ ਪ੍ਰਕਾਰ ਦੇ ਕਿਸੇ ਚੁਣੇ ਹੋਏ ਪੈਮਾਨੇ ਜਾਂ ਨਿਰਧਾਰਿਤ ਮਾਪਦੰਡਾਂ ਨਾਲ ਕਰਨ ਦੀ ਲੋੜ ਹੁੰਦੀ ਹੈ। ਜਿਸ ਉੱਤੇ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦਾ ਮਾਪ ਆਧਾਰਿਤ ਹੁੰਦਾ ਹੈ, ਉਸ ਨੂੰ ਮਾਤਰਾ ਦੀ ਇਕਾਈ ਜਾਂ ਯੂਨਿਟ ਆਫ ਦੈਟ ਕੁਆਂਟੀਟੀ ਕਹਿੰਦੇ ਹਨ। The process of measurement of a physical quantity involves the selection of unit and to find out the number of times that unit is contained in the physical quantity. However, measure of a physical quantity is equal to the numerical value of the physical quantity times the size of its unit. If U is the size of the unit and N is the numerical value of the physical quantity, then measure of the physical quantity is NU. If U1 and U2 are two different units of same physical quantity, let n1 and n2 are the numerical values of the physical quantity in terms of the mentioned units respectively. Then n1 u1 is equal to n2 u2. Dimensional analysis is generally used to check the probable correctness of derived equations and computations. It is also used to form reasonable hypotheses about complex physical situations that can be tested by experiment or by more developed theory of the phenomena. Dimensions of a physical quantity are the powers to which the fundamental units of mass, length, time, electric current, and temperature have to be raised in order to obtain its units. It should be clear that the dimensions are not merely a power but a combination of basic quantities and their power. Both are taken together and hence represented together. We may keep in mind that units follow dimensional constitution. A pair of square bracket is used to represent the dimension of individual basic quantity with its symbol enclosed within the bracket. There is a convention in using symbol of basic quantities. The dimensions of main basic quantities are represented as mass by capital M, length by capital L, time by capital T, electrical current by capital A, temperature by K, luminous intensity by small cd, and amount of substance by small mol, pronounced as mole. We can see here that there is no pattern. Sometimes we use initial letter of the basic physical quantity like m. Sometimes we use initial letter of basic unit like a. ਕਿਸੇ derived quantities ਦੀ dimensions ਨੂੰ ਕੁਝ ਜਾਂ fundamental quantities ਦੀਆਂ dimensions ਰਾਹੀਂ ਠੀਕ ਅਭਿਵਿਅਕਤ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। ਕਿਸੇ derived quantity ਦੀ dimensions ਨੂੰ ਲਿਖਣ ਦੀ ਟੈਕਨੀਕ ਨੂੰ ਸਮਝਣ ਲਈ ਆਓ ਅਸੀਂ ਕੁਝ examples ਵੇਖਦੇ ਹਾਂ। Area as unit area is unit length multiplied by unit length. Hence, the dimensions of area is L square. Volume as unit volume is unit length multiplied by unit length further multiplied by unit length. Therefore, the dimensions of volume is L cube. Velocity as unit velocity is unit length divided by unit time. Therefore, the dimensions of velocity is L t minus 1. ਆਓ ਅਸੀਂ ਫੋਰਸ ਤੇ ਵਿਚਾਰ ਕਰਦੇ ਹਾਂ। ਫੋਰਸ ਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਪਰਿਭਾਸ਼ਿਤ ਕੀਤਾ ਜਾਂਦਾ ਹੈ F ਬਰਾਬਰ m ਅਤੇ a ਦੇ ਗੁਣਨਫਲ ਦੇ। ਇਉਂ ਫੋਰਸ ਦੀ ਡਾਇਮੈਂਸ਼ਨਸ ਹਨ ਮਾਸ ਦੀ ਡਾਇਮੈਂਸ਼ਨ ਅਤੇ ਐਕਸਲਰੇਸ਼ਨ ਦੀ ਡਾਇਮੈਂਸ਼ਨ ਦਾ ਗੁਣਨਫਲ। The dimension of acceleration represented as a in square bracket is again a derived quantity which is the ratio of velocity and time. We know that velocity is also a derived quantity equal to the ratio of length and time. Hence, the dimension of force is equal to the product of dimension of mass and dimension of velocity divided by the dimension of time, which is further equal to the product of dimension of mass and dimension of length divided by the square of the dimension of time. In short, dimension formula for force is mLt minus 2. Dimension formula for force can be read as one dimension in mass, one dimension in length and minus 2 dimension in time. In short, dimension formula for force is mLt minus 2. This emphasizes that the dimension is not merely a power but combination of basic quantities and their powers. ਜਾਂ ਅਸੀਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਕਿ derived quantity ਦੀ dimensions ਹਮੇਸ਼ਾ ਉਸ ਦੇ dimensional constitutions ਦੇ ਅਨੁਸਾਰ ਹੀ ਅਭਿਵਿਅਕਤ ਕੀਤੀ ਜਾਂਦੀ ਹੈ। ਫੋਰਸ ਦੇ ਕੇਸ ਵਿੱਚ dimensional formula ਹੈ m l t-2। ਇਸ ਦੀ SI ਯੂਨਿਟ ਹੋਵੇਗੀ ਕਿਲੋਗ੍ਰਾਮ ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ ਸਕੁਅਰ, ਪਰ ਇਸ ਨੂੰ ਅਸੀਂ ਇੱਕ ਸਿੰਗਲ ਨਾਂ ਦਿੱਤਾ ਹੈ ਜੋ ਕਿ ਨਿਊਟਨ ਹੈ। ਫਿਜ਼ਿਕਸ ਵਿੱਚ ਅਜਿਹੇ ਐਗਜ਼ਾਮਪਲਸ ਕਾਮਨ ਹਨ। Furthermore, in mechanics, we generally use all three symbols corresponding to three basic quantities, that is m, l and t, which may or may not be involved. If a derived unit has the nth power of a fundamental unit, it is said to be of n dimensions in that unit. If a physical quantity x involves all the three fundamental units m, l and t with powers a, b and c, then we may write the dimensions of x as m to power a, l to power b and t to power c. This is called dimensional formula. However, the equation obtained when a physical quantity is equated with its dimensional formula is known as dimensional equation. In the dimensional equation, we may write x equal to m to the power a, l to the power b and t to the power c. In this equation, the right hand side represents the dimensional formula of physical quantity x, whose dimensions in mass, length and time are a, b and c respectively. If one or two of the basic quantities are not present, it is considered conventional to report absence of the dimension in a particular basic quantity. It is represented by raising the power of the concerned symbol to 0. For example, the dimensional formula for acceleration is L t-2, but we may write it as m to power 0, l raised to the power 1 and t raised to the power -2. In general, dimensional formula of a physical quantity may be defined as the expression that indicates which of the fundamental units of mass, length and time exists into the derived unit of that quantity and with what powers. ਆਓ ਕੁਝ ਦੂਜੀਆਂ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀਜ਼ ਨਾਲ ਉਹਨਾਂ ਦਾ ਸੰਬੰਧ ਪਰਿਭਾਸ਼ਿਤ ਕਰਨ ਤੋਂ ਬਾਅਦ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀਜ਼ ਦੇ ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲੇ ਦਾ ਪਤਾ ਕਰੀਏ। Before continuing further, let me tell you the process to determine the dimensional formula of any physical quantity. Each of the basic dimensions forms a group in dimensional formula. For example, let us consider a physical quantity work. We know that the work is the product of force and displacement. The basic dimension length is present in both force and displacement. Therefore, dimension in length forms a group, one from force and one from displacement. The dimension in the group is operated by multiplication rule of indices. That is, for the multiplication of numbers of the same base, we add the indices. If n is the power of x and m is the power of another x, then the product of x to the power n and x to the power m is equal to x to the power n plus m. ਕਿਸੇ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦੇ ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲਾ ਨੂੰ ਨਿਰਧਾਰਿਤ ਕਰਨ ਦੀ ਬੁਨਿਆਦੀ ਵਿਧੀ ਹੈ ਉਸ ਦੀ ਪਰਿਭਾਸ਼ੀ ਸਮੀਕਰਨ ਜਾਂ ਸੰਬੰਧ ਨੂੰ ਵਰਤਣਾ। ਇੱਥੇ ਮੈਂ ਤੁਹਾਨੂੰ ਯਾਦ ਕਰਵਾ ਦਿਆਂ ਕਿ ਬਲ ਦੀਆਂ ਡਾਇਮੈਂਸ਼ਨਸ ਪਤਾ ਕਰਨ ਲੱਗਿਆਂ ਅਸੀਂ ਫੋਰਸ ਦੇ ਮਾਸ ਐਂਡ ਐਕਸਲਰੇਸ਼ਨ ਵਾਲੇ ਰਿਲੇਸ਼ਨ ਨੂੰ ਵਰਤਿਆ ਸੀਗਾ। ਅਸੀਂ ਇਸ ਰਿਲੇਸ਼ਨ ਵਿਚਲੀਆਂ ਰਾਸ਼ੀਆਂ ਨੂੰ ਅੱਗੇ ਡੀਕੰਪੋਜ਼ ਕਰਕੇ ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲਾ ਨਿਰਧਾਰਿਤ ਕੀਤਾ ਸੀ। ਇਹੀ ਆਦਰਸ਼ ਤਰੀਕਾ ਮੰਨਿਆ ਗਿਆ ਹੈ। Let us start with momentum. It is equal to the product of mass and velocity. Hence, its dimension formula would be mlt minus 1 and its SI unit would be kilogram meter per second. Similarly, we can find out the dimension of pressure. Pressure is force per unit area. Hence, its dimensional formula is m L minus 1 T minus 2 and hence its SI unit is kilogram per meter per second square, which is also known as Newton per meter square or Pascal. Can you tell me the dimension of work or energy? Energy or work is the product of force and distance. Hence, its dimensional formula is m L2 T minus 2 and therefore its SI unit is kilogram meter square per second square, which is also known as joule. Similarly, we can find out the dimension of impulse. Impulse is the product of force and time. Hence, its dimensional formula is m L T minus 1 and so its SI unit is kilogram meter per second, which is also known as Newton second. ਕੀ ਤੁਸੀਂ ਮੈਨੂੰ ਦੱਸ ਸਕਦੇ ਹੋ ਕਿ ਸਪੈਸਿਫਿਕ ਹੀਟ ਕੈਪੈਸਿਟੀ ਦੀ ਡਾਇਮੈਂਸ਼ਨ ਕੀ ਹੈ? Specific heat capacity is the heat energy per unit mass per unit temperature. Hence, its dimensional formula is L2 T minus 2 K minus 1 and its SI unit would be meter square per second square per Kelvin or joule per Kelvin. ਕੀ ਤੁਸੀਂ ਮੈਨੂੰ ਦੱਸ ਸਕਦੇ ਹੋ ਕਿ ਚਾਰਜ ਦੀ ਡਾਇਮੈਂਸ਼ਨ ਕੀ ਹੈ? We know that the current is the rate of flow of charge or charge is the product of current and time. Hence, the dimension of charge is T, A and the SI unit would be ampere second, which is also known as coulomb. I hope you can find out the dimensions of resistance. Resistance is equal to electric potential per unit current, whereas the electric potential is the work per unit charge. Hence, the dimension of resistance is M L2 T minus 3 A minus 2. However, its unit is ohm, but 1 ohm is kilogram meter square per second cube per ampere square. Similarly, the dimensions of other physical quantities can be written from the definition of that quantity. ਤੁਹਾਡੇ ਨੋਟ ਕਰਨ ਲਈ ਇੱਕ ਖਾਸ ਮਹੱਤਵਪੂਰਨ ਗੱਲ ਇਹ ਹੈ ਕਿ ਕਿਸੇ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦੀ ਅਭਿਵਿਅਕਤੀ ਵਿੱਚ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦੀ ਆਪਣੀ ਮਾਤਰਾ ਨਹੀਂ ਹੁੰਦੀ। ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲਾ ਕੁਆਂਟੀਟੀ ਦੀ ਨੇਚਰ ਦੀ ਪਛਾਣ ਨਹੀਂ ਕਰਦਾ। ਉਦਾਹਰਨ ਦੇ ਤੌਰ ਤੇ ਟਾਈਪਸ ਆਫ ਫੋਰਸ have no bearing on its dimensional representation and variants of a physical quantity bears the same dimensional representation. For example, velocity. It may be instantaneous or average or relative has the same dimensional representation, that is L T minus 1. ਇਸ ਤੋਂ ਅੱਗੇ ਕਿਸੇ ਵੈਕਟਰ ਰਾਸ਼ੀ ਅਤੇ ਉਸਦੇ ਸਕੇਲਰ ਸਾਥੀ ਦੀ ਡਾਇਮੈਂਸ਼ਨਲ ਅਭਿਵਿਅਕਤੀ ਇੱਕੋ ਜਿਹੀ ਹੋਵੇਗੀ। ਉਦਾਹਰਨ ਦੇ ਤੌਰ ਤੇ ਵੈਲੋਸਿਟੀ ਅਤੇ ਸਪੀਡ ਦੀਆਂ ਡਾਇਮੈਂਸ਼ਨਸ ਇੱਕੋ ਹੀ ਹਨ। Do you know that the dimensions of the difference of a physical quantity are same as that of physical quantity itself? For example, dimensions of velocity and difference of two velocities are same. Quantities whose measures do not depend upon the choice of the units are called dimensionless quantities. This is possible where physical quantities are equal to the ratio of quantities having same dimensions. For example, let us consider the case of an angle, which is a ratio of arc and radius. Since both arc and radius are the measure of length. Therefore, dimensions of such types of physical quantity are 0 in each of the basic quantities. Similar to angle, Reynolds number used in fluid mechanics also does not have dimensions in basic quantities. Reynolds number is equal to density of the fluid multiplied by diameter of the tube, further multiplied by the fluid velocity and divided by the coefficient of viscosity. On substituting the dimensional formula for each quantity, it can be found that Reynolds number is also dimensionless quantity. ਇਸ ਤੋਂ ਇਹ ਪਤਾ ਚੱਲਦਾ ਹੈ ਕਿ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਜਾਂ ਤਾਂ ਡਾਇਮੈਂਸ਼ਨਲ ਹੋ ਸਕਦੀ ਹੈ ਜਾਂ ਡਾਇਮੈਂਸ਼ਨ ਤੋਂ ਬਗੈਰ। ਡਾਇਮੈਂਸ਼ਨ ਤੋਂ ਬਗੈਰ ਭੌਤਿਕ ਰਾਸ਼ੀ ਦੀਆਂ ਕੋਈ ਡਾਇਮੈਂਸ਼ਨਲ ਇਕਾਈਆਂ ਨਹੀਂ ਹੁੰਦੀਆਂ ਕਿਉਂਕਿ ਇਸ ਦੀ ਕੋਈ ਡਾਇਮੈਂਸ਼ਨ ਨਹੀਂ ਹੁੰਦੀ। ਕਿਉਂਕਿ ਰੇਨੋਲਡਸ ਨੰਬਰ ਇੱਕ ਸੰਖਿਆ ਹੈ, ਇਸ ਲਈ ਇਸ ਦੀ ਕੋਈ ਡਾਇਮੈਂਸ਼ਨਲ ਯੂਨਿਟ ਨਹੀਂ ਹੁੰਦੀ। ਹਾਲਾਂਕਿ ਇਸ ਦੇ ਅਪਵਾਦ ਵੀ ਹੁੰਦੇ ਹਨ। ਉਦਾਹਰਣ ਦੇ ਤੌਰ ਤੇ ਐਂਗਲ ਲੈਂਦੇ ਹਾਂ। ਇਹ ਇੱਕ ਡਾਇਮੈਂਸ਼ਨ ਤੋਂ ਬਗੈਰ ਰਾਸ਼ੀ ਹੈ, ਪਰ ਇਸ ਦੀ ਡਾਇਮੈਂਸ਼ਨਲ ਯੂਨਿਟ ਹੈ ਜਿਸ ਨੂੰ ਰੇਡੀਅਨ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। Some other examples of dimensionless quantities are number, solid angle, Poisson's ratio, refractive index, strain, specific gravity, angular displacement, magnetic susceptibility, relative permittivity, ratio of specific heats, and Mach number. On the other hand, there are numerical constants like trigonometric functions, logarithms, pi, quantities which are simply counted, etc. Do not depend on the basic physical quantities. We can define the dimensions of such a constant as 0 in each of the basic quantities. Therefore, they are known as dimensionless constants. However, it is not necessary that every physical constant is dimensionless. There are physical constants which appear as the constant of proportionality in physical formula, and such constants have dimensions in basic quantities. For example, gravitational constant, Boltzmann constant, Planck's constant, etc. Such type of constants are dimensional constant. Let us have a look on the dimension of such type of physical constant. We know that the gravitational constant is equal to the force between two objects multiplied by the square of the distance between them and divided by the product of their masses. Hence, dimension of gravitational constant is m minus 1 L3 T minus 2 and its SI unit is meter cube per kilogram per second square or Newton meter square per kilogram square. Similarly, we can find out the dimensions of Planck's constant, which is equal to energy per unit frequency. Hence, its dimension formula is m L2 T minus 1 and its SI unit is kilogram meter square per second, which is also known as joule second. In general, on the basis of dimensional formula, we categorize the physical quantities into 4 categories. One is dimensional variables. The quantities which have dimensions and do not have a constant value are called dimensional variables. For example, area, volume, speed, force, current, etc. Next category is non-dimensional variables or dimensionless variables. The quantities which neither have dimensions nor do they have a constant value are called non-dimensional variables. For example, angle, specific gravity, strain, trigonometric functions, logarithmic functions, etc. Next category is dimensional constants. The quantities which have dimensions as well as a constant value are called dimensional constants. For example, gravitational constant, Planck's constant, permittivity, etc. The last category is non-dimensional constants or dimensionless constants. The constants quantities having no dimensions are called non-dimensional constants. For example, pure numbers, mathematical constants, all trigonometrical ratios, etc. You can notice that two or more physical quantities may have the same dimensional formula. In a set of such quantities, all of them may be scalars or all vectors, or some scalars and others vectors. Let us see the examples of such sets. Pressure, stress and elastic modulus have the same dimensional formula as m L minus 1 T minus 2. Frequency, decay constant, decay rate, angular frequency, velocity gradient all have dimensional formula as T minus 1. Wave number, focal power and Rydberg's constant have dimensional formula as L minus 1. Angular momentum and Planck's constant has dimensional formula as m L2 T minus 1. Similarly, force constant, surface energy and surface tension have dimensional formula as m T minus 2. Many physical quantities have the same dimensions, but it is not necessary that they are similar quantities. All may have their different meaning. For example, work, energy, torque and moment of couple also have the same dimensions, but they have their different physical meanings. पर डायमेंशनल इक्वेशंस ਦੇ ਕੁਝ ਮਹੱਤਵਪੂਰਨ ਉਪਯੋਗ ਹਨ, ਜਿਵੇਂ ਕਿ ਡਾਇਮੈਂਸ਼ਨਲ ਇਕੁਏਸ਼ਨਸ ਨੂੰ ਕਿਸੇ ਫਿਜ਼ੀਕਲ ਇਕੁਏਸ਼ਨ ਦੀ ਕਰੈਕਟਨੈਸ ਚੈੱਕ ਕਰਨ ਲਈ ਵਰਤਿਆ ਜਾ ਸਕਦਾ ਹੈ, ਕਿਸੇ ਫਿਜ਼ੀਕਲ ਫੈਨੋਮੇਨਨ ਵਿੱਚ ਸ਼ਾਮਲ ਵੱਖੋ ਵੱਖਰੀਆਂ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀਜ਼ ਵਿਚਾਲੇ ਸੰਬੰਧਾਂ ਨੂੰ ਸਥਾਪਿਤ ਕਰਨ ਲਈ ਵੀ, ਅਤੇ ਇੱਕ ਸਿਸਟਮ ਆਫ ਯੂਨਿਟਸ ਤੋਂ ਦੂਜੇ ਵਿੱਚ ਬਦਲਣ ਲਈ। ਇਹਨਾਂ ਸਾਰੇ ਉਪਯੋਗਾਂ ਨੂੰ ਅਸੀਂ ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਵਿਚਾਰਾਂਗੇ। Let us summarize today's topic. Dimension usually denotes the physical nature of a quantity, regardless of the units in the measurement. It is generally used to check the probable correctness of derived equations and computations. Can you define dimensions of a physical quantity? Dimensions of a physical quantity are the powers to which the fundamental units of mass, length, time, electric current and temperature have to be raised in order to obtain its units. Dimensions are a combination of basic quantities and their power. Dimensions of main basic quantities are represented as mass by m, length by L, time by T, electrical current by A, temperature by K, luminous intensity by CD, and amount of substance by mole. Dimensions of a derived quantity are always expressed in accordance with its dimensional constitutions. If a physical quantity X involves all the three fundamental units m, L and T with powers A, B and C, then we may write the dimension of X as m to the power A, L to the power B and T to the power C. This is called dimensional formula. Can you give general representation of a dimensional equation? In general, a dimensional equation may be written as x equal to m to the power a, l to the power b, and t to the power c. If one or two of the basic quantities are not present, it is considered conventional to report the absence of the dimension in a particular basic quantity. It is represented by raising the power of the symbol to 0. For example, the dimensional formula for velocity is Lt minus 1, but we may write it as m to power 0, L raised to power 1, and T raised to the power minus 1. The basic approach to determine dimensional formula of a physical quantity is to use its defining equation. Now, can you define dimensional variables? The quantities which have dimensions and do not have a constant value are called dimensional variables. For example, area, speed, energy, charge, etc. Then, what are non-dimensional variables? The quantities which neither have dimensions nor do they have a constant value are called non-dimensional variables. For example, angle, trigonometrical and logarithmic functions, etc. Do you remember what are dimensional constants? The quantities which have dimensions as well as a constant value are called dimensional constants. For example, gravitational constant, Planck's constant, etc. On the other hand, the constant quantities having no dimensions are called non-dimensional constants. For example, pure numbers, mathematical constants, etc. However, many physical quantities have the same dimensions, but it is not necessary that they are similar quantity. For example, linear momentum and impulse has the same dimension, but they have their different physical meanings. So now we come to the end of the today's topic. Here is a quick test for you. Can you find out the dimensional formula for power? Dimensional formula for power is m L2 T minus 3. Now find out the dimensional formula for resistivity. Dimensional formula for resistivity is m L3 T minus 3 A minus 2. Are the dimensional formulas for energy and torque same or not? Both have the same dimensional formula, which is m L2 T minus 2. I hope you enjoyed the lesson and looking forward to the next class. Thank you for your attention and see you next time.